Hey guys, welcome back to my YouTube channel. I hope you all are doing well and you all are in great health. If you have liked my previous video, I would like to thank you all. So, before moving to today's video, if you're a newcomer to this channel, let me introduce myself. I'm Karthik Agrawal, currently studying in Sri Venkateshwara College of Engineering. Now, let's dive into today's topic. Today, we're here to talk about an exciting topic that is computer aided engineering drawing or CAD. So let's begin with understanding what is CAD software. Computer aided design software is a combination of hardware and software that helps designers to create and document designs and technical drawings in 2D and 3D. CAD software is used in many industries, including aerospace, electronic, and manufacturing industries. It can help to improve design quality, increase productivity, and improve record keeping. I hope you all have understood the basics of CAD software. Some points to remember. As you can see in the given diagram, we can create 2D orthographic projection of an object such as top view, front view, and side view. Note top front view with the help of a single quotation mark, whereas top view without any quotation marks and side view with double quotation marks. One more point to remember that we have different kinds of lines in orthographic projections such as continuous line, broken line, hidden line, center line, etc. In CAD, there are mainly two types of lines, thick line and the thin line. Thick lines are the visible lines, whereas thin lines are the non visible lines or imaginary lines. I hope you all have understood this much. Now, hey guys, I hope you all have understood the animated explanation of the orthographic projection. Now let me help you to solve a following sum in orthographic projection. As you can see the following screen, there is a question that displays a line of AB is 75 mm long and it is inclined at 30° and 40° to HP and VP respectively. The end A is 12 mm above HP and 10 mm in front of VP. Draw the projections of the line and determine its measurement. Now the part which I am going to explain, no need to draw this. First draw the quadrant axis for better explanation, and according to the sum, consider this to be an inclined line. A point to remember that whenever you get a sum related to lines and planes, always consider first angle method. That is, we have to draw the following object in first quadrant. Now, according to the question, this inclined line is inclined at 30° with respect to its HP and 40° with respect to its VP. Now let's understand how to draw its orthographic projection. First consider an XY thin continuous line. As I've earlier mentioned, thin continuous line means non-visible line and we have to consider the width of 0.35 mm. So draw a straight line. At the end of the cursor you can find a symbol that displays that the drawn line is straight or not. So first draw the straight line. Now with the help of text option, write X and Y. Now, whenever you see a question where it says the end is above HP means we have to draw a reference line above the XY axis. And according to this question, we have to draw a 12 mm line about XY axis. So we can do this with the help of offset method. So click on the offset method and click on the XY axis. Since it says 12 mm above HP, so you can just type your 12 mm and click enter or accept, and after that you can get an imaginary line of 12 mm. Similarly, it also says that 10 mm in front of VP. And whenever you find in a question where it says in front of VP means draw a reference line below the XY axis. So according to this question, we have to draw 10 mm reference line in front of VP, that is below XY axis. So again with the help of offset option, this time click on XY axis and now click on 10 mm and center and selected. As you can see, we have got two reference line, but we want the it's better to display the dimensions at the corner. So just move delete this from here, and then with the help of distance between, click on XY axis and the reference line above the XY axis. Similarly, click on the XY axis and the reference line below the XY axis. Now as you can see, it's all done. Now let's name these two reference axes, such as locus of A dash and locus of A. Now if you may wonder why I have written A dash and A, since I have said that we are using first angle method, so the front view of the following sum is always above XY axis, and the top view of the following sum is always below XY axis. Since we are using first angle method, so above XY axis is VP and below XY axis is the HP. VP and HP stands for vertical plane and horizontal plane. Now as per the question, the line AB is of 75 mm. As you know, 75 mm here represents the true length of the line, and due to and when we find its true and when we find its front view and top view, you may find that the length of the following line changes. Now let's see what are the actual length of this line. So first consider a reference straight line like this. It helps us to draw the following sums. Make sure this reference line is of 0.13 and like this. Now let's name the reference points, such as here it would be A dash, indicating that the front view of the point lies here, and here would be A. Now from here, draw a 75 mm line. So click on A dash, you can find a point symbol at the end of your cursor. From there, write 75. This says that this 75 mm line is inclined at 30 degree to its HP. So at inclined at 30 means consider this line to be inclined at 30 degree. So write here 30. You got the following AB line. So name at this point. So let's name this end as B1 dash. Now let's draw a locus for B1 dash, such as consider this. As I have earlier mentioned, locus means broken lines, and we can get broken lines by clicking on this. Just click here, and as you can see, we have got a broken lines. So let's name this locus of B1 dash. Now let's follow the same steps for top view true length, such as click on the point A, write 75. This time it says that it is inclined at 40 degree to VP. So the angle should be 40 degree. So write minus 40. So we'll get a 40 degree line. As you can see, it should be a straight line. No need to delete this. Just click on the following line. Go to style option, go to type option, and click on continuous line. You can find 75 mm continuous straight line. Now let's name this end point as B1. Now let's draw the locus for this point also. So again click on, as you can see, it's continuous line. Just click on this. It should be a straight line, and let's name this locus as locus of B1. Till now I hope you all have understood this video. Now let's see how can we draw its front view and its top view. To draw its front view, first consider the point B1 dash and check whether it's a continuous line. Yeah. Consider the point B1 dash and draw a straight continuous line till locus of A and make sure these two intersect at a point. Now consider tangent arc option and there click on arc by center point. We use this option to cut an arc from A A point to the intersection point of locus of A and the straight line. Be careful and cut an arc till it touches locus of B1 dash. Now just join these 2 points, that is A point and the intersection point between the locus and the arc. Make sure this time it is a thick line, as thick line represents in orthographic projections as visible line. So front view are the visible line, so draw a thick line. As top view are visible line, so draw a thick line. Now let's do the same step to find the front view of a following sum. So again click on line option. This time make it again to 0.13. Click on B1 point. From there draw a straight line to locus of A. Then cut an arc with the help of arc by center point where you will find in tangent arc option. This time keep first point at A dash, then at the intersection point and draw one arc till it intersects locus of B1. Now draw a straight thick line. So again go and change the width to 0.50 mm and this is a front view. Now let's name this point and this point. With the help of text option, let's name this point as V1 and this point as V. Now let's find the dimensions of each line. With the help of smart dimensions, you can check what's the actual length of the true length. It shows as now it shows as 75 mm as we know. Now let's find the dimensions of a front view. This that shows 57,45. Your comma represents point. So the actual length of the front view is 57.45 mm. Similarly show the dimension for here also, and now let's find the length of top view, that is 64,76. This means 64.76 mm is the length of front view. Let's check its inclinations also with the help of angle between. Since we know the true length and the true length is inclined to 30-degree, as you can see. Now let's find the front view inclination by clicking on the front view and this line and locus of A. We can find that the front view is inclined at 41-degree, and as we know that the true length for the top view was inclined at 40-degree. Now let's check the top view inclination. So click on the top view line and click on the locus of A line, and as you can see we can find the inclination of its top view, that is 48-degree. Let's draw the directions of these lines. This we can do with the help of leader option, and as we know this line is going downward, so click on this line and move it downward, and this line is moving towards its left side, so click on that arc line and show it. Similarly, we know this line is going upwards, so click on this and this line is also moving to its left direction. So, like this. I hope you all have understood this sum. Thank you for watching.
Now, let's understand to the next subtopic, that is applications of CAD software. As CAD software has many applications, but I have listed few applications such as how CAD software is used in construction, engineering, and computer animation. In construction, CAD software is used to create detailed plans for buildings, bridges, roads, and other infrastructure projects. These plans include architecture drawing, structure design drawing, and mechanical, electric, and plumbing drawings. With the help of these, we can find the details of layouts and also about beams, columns which are required in a building. Now, let's see how CAD software is used for engineering. In engineering, CAD software plays a vital role in creating highly accurate digital representation of designs. These digital models serve as the foundation for various engineering disciplines, including architects and engineers too. They also help in visualize and refine designs, improve accuracy and efficiency, enhance communication and collaboration, and also helps us to stimulate real world conditions. Now let's see how CAD software is used in animations. While CAD software is traditionally used for engineering purpose, CAD software becomes a powerful tool in the world of computer animation, and it plays the following roles. It helps us to create 3D modeling for animation. It also helps in character designing. It helps in rigging of a character, that is movement of a character, and it helps in integration with animation software. I hope you all have understood this much. Now let's move on to the next topic, that is advantages of CAD software. CAD software has many advantages, but I've listed some advantages such as increased productivity. CAD automates things like dimensions, adding hatching patterns, and generating bills of material. This frees up engineers to focus on the creative aspects and complete projects faster. CAD has another advantages, that is improved communication. CAD software lets us to create clear drawing and realistic rendering. This makes it easier for everyone involved, from engineers to the clients, to understand the design, reducing confusion and miscommunication. Now let's understand another advantage of CAD software, that is enhanced accuracy. CAD offers features like snapping of grids, automatic constraint checks, and revision control. These tools ensure precise models and minimize the risk of mistakes that can be costly to fix later. Now let's understand the last advantage of CAD software, that is design iteration. CAD software allows easy and quick modification for greater exploration of ideas and faster optimization of the final product. I hope you all have understood the advantages of CAD software. Now let's move on to the some challenges faced by CAD software. Even with undeniable strength, CAD software presents few challenges which needs to be considered. Learning curve. Unleashing the full potential of CAD software requires dedication and practice. The feature rich programs can be complex, demanding significant investment in training to become proficient. This can be a barrier for new users or those with limited technical expertise. Now, let's see another challenge faced by CAD software, that is hardware demands. Complex CAD models and rendering capabilities push the boundaries of computer processing power and graphic capabilities. To run smoothly these programs, we often require powerful workstations with high end components. This can translate to a significant investment, especially for individuals, user, or small companies. Now, let's understand another key challenge faced by CAD software, that is data management. The complexity of 3D CAD models can translate to large file sizes. This makes data storing, managing, and sharing difficult. Cloud based solutions can help in this issue, but internet connectivity and storage limitation can be still key factors. Now let's understand last key challenge faced by CAD software, that is security concerns. Protecting sensitive designs data from unauthorized access or breaches is a growing concern, especially with the risk of cloud based CAT solutions. Implementing robust security measures is crucial to safeguard intellectual property. I hope you all have understood this brief and concise explanation of CAT software. If you do like this video, please don't forget to hit the thumbs up button and subscribe to my channel. Thank you very